Welcome to This Wasn't on the Test, the podcast where knowledge meets humor in the most unexpected ways. Join Dr. Jake and Dr. Kayla, a couple with doctorates in their respective fields, and their sister Kelsey, who may not have a PhD but sure knows how to keep things light with her quick humor and relatable take on the world. Whether you're a scholar or just a curious mind, this trio will make you laugh, think, and you might even learn something new. Tune in to find out why this wasn't on the test. Welcome back to This Wasn't on the Test. I'm Kelsey, and I'm here with my brother, Dr. Jake Berg, and my sister-in-law, Dr. Kayla Berg.
Hello.
Back at it again.
Doing it again. Another short episode.
Another short episode, yep. So this week on the podcast, Jake is sharing.
Yep.
Yeah. Short episodes, i.e. like normally length episodes for us.
Because we're
or like for like normal people.
Because we're chatting
because we can't just shut up.
Motherfucker.
Yeah.
Listen, would you like
we just yap and yap.
Would you like your niece has started middle school update?
Yes.
So last night she did her first big.
Does she have a boyfriend?
No, she doesn't have a boyfriend. She is uninterested.
Okay. Yeah, she hasn't shown any interest in that department.
No, uninterested. And she gets like if you ask her about it, she gets not like embarrassed, annoyed, but just like, why are you talking to me about this? Like, why? Just uninterested. No, but she did go to her first middle school basketball game last night. She had two of her friends playing, and one of other friends was going. So she's like, I want to go to the basketball game. And so I'm like, well, I've got some work I need to get done anyways. So I took her to the game, and I'm like, all right, here's your concession stand money. Text me if you need something. I'll be upstairs. So she got to, have a little bit of independence and be at the basketball game with her friends, and it was a whole thing.
Aw, cute. Did she bring some alcohol in a little flask?
No.
That's what I would have
Injected into an orange?
Injected? No.
Yeah.
She was excited for the $10.
I'll have to teach her the tricks.
She was excited for the
Just
$10 in cash she got to spend at the concession stand.
Wow. That's a lot of money to spend at a concession
Well,
stand.
she ended up buying a snack for her friend that she was sitting with and buying. I'm just like, don't. And she still has like $3 left over. She spent like $7.
Nice.
But so that was her first big middle school
she's growing up.
moment. I'm like, yeah, I'll take you to the game. I'm like,
well, I have something to teach you guys this week.
All right, let's hear it.
Okay.
Sweet. Okay. So you guys know how I cry all the time, like so easily over like things, right?
Yes.
Like
I was waiting for you to cry about Emmy going to a basketball
doesn't matter what
game.
it is. Yeah, that for some reason isn't getting me. I don't know. So I was scrolling TikTok the other day, and all of a sudden I come across this girl, and she's like, does anybody else have that, like where you just like cry so easily over things, and like there's like no like real reason why, like you just like really like you get choked up really easily. And I was like, oh my god, it's me. And she was like, there's actually a term for it. Can you believe it?
You and your mother both have this.
Yes. It's called collective effervescence. Have you ever heard of that?
Effervescence. I mean, I know both of those words.
Yeah.
Sounds made up.
Sounds made up. Sounds like some TikTok syndrome.
Sounds made up. So like a bunch of people are talking about it online. And so then I asked ChatGPT because Chat knows all. And it is an actual thing. It's a collective effervescence is a sociology term coined by Emil Durkheim, however you say your name, to describe the electric, energizing feeling that people get when they come together in a group or share the same focus or feel emotionally connected. And it's like,
see, but you cry all by yourself.
Yeah, what you're saying sounds more like people are going to a concert and all having a good time together.
I mean, I cry then too.
Right, which that sounds like,
but like I'll cry
effervescence.
But like I'll cry when like watching like a sporting event on TV, and I'm not even with anybody. It's just me, and it's like I still get that same energy off of that, and I think that's why I cry.
I get it. I think you can stretch the definition for it. I see it.
I think you're just a bitch, baby.
Yeah, that's exactly what I am.
Oh, here we are.
100%. 100% bitch. I'm 100% that bitch, baby.
I mean, there's a span of years where I think you were cold and dead, and now you cry about everything.
True. I was cold and dead for about 10 whole years.
I'm aware. I can
didn't
identify
cry
the
literally
exact
like
10
ever
years.
in those years. Yeah. So, I mean, we're doing better. Still dead inside, but I can cry.
I think you're just trying to get it. You got to get it all out now because you stored it up for 10 years.
Yeah.
That's why,
true.
So
Maybe that's what it is.
Well, I'm glad to hear you're not cold and dead inside anymore. At least emotionally. You're not emotionally dead.
So yeah, that's what I'm teaching you guys today. That's all I got. I've got nothing else.
I appreciate that.
Thank you. Yeah, you're welcome.
E for effort.
Truly. My pleasure.
You did well on that. I give that a D.
A D.
Remember, we got our backwards
in
grading scale.
In the backwards grading scale. Did good.
Yeah, definitely above. Come on.
So.
Definitely above. Come on.
Great. Usually I get a come on. Or a ah.
Oh my God. I swear to God, I'm going to type up this grading scale and post it in my classroom.
You 100%
because
should.
The brilliant assholes that I teach would fucking die. They would live for this.
Yeah. That's hilarious. I love that.
All right.
Should we fast track into our spelling bee portion? Because I am very much looking forward to it.
Yes, I think we should.
This is the part where we give each other hard to spell words and make fools of ourselves segment.
I would like it noted that on last episode, I was the only person to spell my word correctly.
You were the only person, so you are winning. It's 1-0. You get 1 point. You have 1 point.
Okay.
Should we keep a running total
I think we
of
should.
Points?
That's not my responsibility.
Keep a running score.
Oh shit. That's okay.
Use your notes app on your phone.
Use my notes app on my phone. I'm gonna finally do something for this podcast, guys.
Wow. Mark the date down, everybody.
I'm here for you all right now in this moment.
Great.
Now you're asking me to
Thank you.
find some really tough ones.
Oh God. No, that's not the point here.
Well, if you're going to make it competitive.
It's not competitive.
Yeah, we are going to make it competitive.
Oh shit. Okay.
Of course. So this section is not yet named, but it will come up. We'll come up with something really good. What?
I just gave it the name.
That's too long. Unless you can make an acronym for it, then I'll accept it.
Okay. That's what physicists are good at. Making acronyms.
Perfect.
Education loves an acronym.
Yeah, I was going to say, we have so many acronyms at school. It's insane. And actually, one of the other people that spoke this week at our college thing said not acronyms, but the other thing that our college does really well is form a committee.
Oh, God, yes.
There's committees for everything.
All right, let's do the spelling.
Okay. Kayla, I'll give you a word first since you're not presenting today.
All right, I'm here for it.
The word that I'm giving you is, that's going to be too easy.
Nope,
it's
going
to be too easy. I got to pull a different one.
Nope, you were prepared with that word. I want that one. I want whatever the one was you had. This feels like cheating.
Give her the science one.
Okay.
Don't give me the science one. That's not how we're doing this.
Oh.
Pipe down. No. Jake, fuck off. He was being facetious.
I wasn't, but...
Okay. Here's the word that I'm going to give you. Pedagogy.
Pedagogy.
Yep.
God damn it.
That was
Kayla.
An easy one. That's an education buzzword.
Well.
Well.
Okay, well, you get another point.
2 points for me. Okay.
Okay, my other word I think is going to be easy too. Fuck. I got to do better. I got to find better words. I'm going to do it. Okay, Jake, your word is gas.
What?
gas.
Can you use it in a sentence?
What's the definition?
No. It means an explosive mixture of hydrogen and oxygen.
I have no idea what this term is. Can you pronounce it slowly?
Gas.
I honestly have no idea because I have no idea what this term is.
You should give him a word he at least knows.
Well, I don't know what words he knows. I'll give you this. Okay, gas is a German word that literally translates to bang gas. It refers to a mixture of hydrogen and oxygen in a 2-to-1 ratio. Highly flammable and explosive. Null gas.
Okay.
Does that help?
Not really. I mean, I'm completely guessing.
Okay.
NALLGAS.
So close, but so far. The correct spelling is KNALLGAS.
Say that again.
Null gas.
Yes. What's the spelling?
KNA. Same what you spelled.
KNA. You pronounce in German. You pronounce the K.
Oh. Canal gas. Can you spell it now?
Yeah. I've still never heard of it.
Well, that's dumb. Well,
where did you even find that? That sounds like a chemistry term.
It is a chemistry term.
Then you're in the wrong
one
subject.
Chemistry class in college.
Well, it's still science, and
but
that's
here's
what I'm going with.
Jake and I have the same amount of chemistry experience. I also took one chemistry class in college.
Great. So you should have spelled that word right.
No, because I took one chemistry class in college.
Okay. Do you want me to give you a different word? Do you want me to give you a different word?
I mean, next time I want you to give me a better word.
Okay. Do you have a word for Kelsey then for this time? Oh, yeah. Here we go.
I got multiple words already.
You got to pick one.
I know.
Perfect.
I'm going to give you spectroscopy.
Ooh.
Oh my God. Okay.
If she gets it wrong, can I try?
Yeah. We used spectroscopy to determine the wavelength of the light.
Okay. This isn't my specialty, so I'm just going to have to take a slam at it. Can you say it one more time?
Spectroscopy.
Spectroscopy. SPECTROPSY.
I think
spectroscopy.
You were right until you paused. I think then you missed, you lost place in the word where you were.
Okay, my turn.
Probably.
I won't count this as a point. I'm not going to count. SPECTROSCOPY.
Yeah, that's correct.
Spectroscopy.
Wow.
Ding, ding, ding.
Have you ever
you
thought
got
about
to
entering a spelling
spectro.
Shockingly, yes. I'm very good at spelling. Actually, Jake and I were just talking about taking the Jeopardy test recently.
Yeah, you should. Spectroscopy.
Spectroscopy. Spectroscopy.
Spectroscopy. Yeah.
But cheese.
I did get lost there. For cheese, it's. I want to throw a party someday where it's a drunk spelling bee, and so like you spend like the first, a little bit like socializing and getting drunk, and then you have a spelling bee with your friends. Doesn't that sound so fun?
Not only does that sound so fun, I have a immediate theory about myself that I'm going to get, silly, can't put a golf ball on a golf tee, drunk, and then I enjoy spelling and am competitive at it so much that I'm going to sober up immediately. The minute we start spelling, I'm going to be stone cold sober, ready to spell. That's how this would go for me.
If you don't win the trophy, I would be disappointed.
Me too.
I had a friend in college who claimed that he could speak Chinese when he was drunk. Like he had a conversation with a Chinese student, and like the person told him afterwards that he had a conversation with them in Chinese, and he's like, I don't know Chinese.
Oh.
So did he know any
That's
Chinese,
a C for come on.
Probably,
at all, ever?
Probably not much more than like ni hao.
So how did his brain?
I don't know. He was just
weird.
like, I don't know how it happened. He's really smart though.
It's like
he's one of the
speaking
smartest.
in tongues.
Yep.
Except for actually real.
Yeah, right. Exactly. Actually, I was talking to one of my employees today, and his spouse is German, and I was like, "Oh, does she speak German?" And he was like, only when she's drunk. I'm like, oh, okay.
Nice.
But she actually like is actually from Germany, so that makes sense.
That's wild. I still like speak Chinese only when you're drunk.
Mm-hmm.
That's wild. All right, should we do this thing?
You want to get into it already?
I'm ready.
Yep.
All right.
Let's hear about it.
So
Can you tell us again what you're talking about?
What are we? Hang
Yeah.
on. How about Kelsey tells us what we're talking about?
No clue.
All right, Jake,
You
go
still
for
have
it.
no clue?
I don't remember. I mean, I knew a couple of, like an hour ago.
We're going to talk about exoplanets.
That's right. Duh. Exoplanets,
are?
Kayla.
Kelsey,
know.
what are
Planets outside of
exoplanets?
our universe.
Outside of our universe?
Nope. Try again. So close.
Outside of our galaxy.
Well, technically, yes.
Outside of our orbit.
Our now you went too small.
Oh.
The moon is in our
I don't know.
orbit.
Isn't it outside of our solar
All
system?
Okay.
outside of our solar system.
Oh.
So
Our solar system.
now
I
what
thought
you
solar
said,
system was like the broader everything.
no, our sun is called Sol, the solar system. Other stars don't have solar systems because they are not the star Sol.
Oh, I never knew that.
Yeah.
Root words are important.
Although I think, and I do this too, I still call it like other solar systems.
Yeah. No,
but-
absolutely.
Conceptually, yeah. But what you said about like other planets and other galaxies, technically those would be exoplanets too, but those are too far away for us to know anything about. So we were talking about planets that are orbiting other stars within the same galaxy that we're in.
Okay.
So,
Cool.
which is very tough to determine because they're so far away, and unlike stars, planets don't give off any of their own light. So the whole trick with exoplanets, yes?
I have a question.
Mm-hmm.
Is this something that the James Webb Space Telescope is going to be able to photograph at some point?
Yes. Now,
So we-
photograph,
But if
I
they
don't
don't
know.
give off light, how will you even see them?
Yeah, so photograph is kind of a weird term. Will they be able to better detect the
Okay.
existence of exoplanets? 100%, absolutely. That's a big reason of why it even exists.
Okay. See, listen, it's all coming together.
Mm-hmm.
I can do science things when it comes to space. For whatever reason, that's the area of science I can science.
So you are getting a little ahead on something here with
Sorry.
that a little bit. But what I was saying is that the planets are so far away and they don't give off their own light. So the trick is finding ways to infer their existence, I suppose. So the people have had to come up with methodologies for like making one observation and going like, well, because this is happening, we can make the, I don't say assumption, but inference is a better word. Inference that there is a planet orbiting this star. So, my first question to you all is, what are some of those methods? How do they detect exoplanets?
Can they
Does it have to do with
Go ahead, Kelsey.
like gases that they're putting off?
Ooh, I like that guess.
You know, it's not on my list, but I think I have. No, I'm going to say no.
Okay.
So close.
An
Can they like
A for ah.
Yeah. On that one.
can they like observe like a void, for lack of a better word? Like there should be something here, but we're not seeing anything, like based on everything else happening around it.
That's called a black hole, Kayla.
So like no, that's not.
I'm going to say no on that one too, but you're starting to dance around a little bit of it.
All right, give it to us.
Like a
You
two-step
want
or
to
what?
come up with another idea?
Like a two, no, more like a waltz.
I want to hear one more idea.
Okay, you want one more idea?
Because do they?
Ooh.
Hmm.
Can they observe like gravitational pull? like something holding gravity, that it like there's other
Yeah,
shit
that
around
is
it.
a big key in this.
There we go. I got one.
Wow.
Kelsey, you're up.
Not
Do they?
Yeah.
Is there? Can they like witness like asteroids or like things crashing into something, and then that kind of marks like, oh, they saw a pattern of explosions or something hitting something?
No, they're too far away to be able to see anything like that.
Oh, wow.
That is kind of how they detect black holes. I
stumped.
think we talked about that a little bit before.
Yeah.
So Kayla, like, gravity is the key player here, but like the way that they make the observations, I think that's you wouldn't be able to get there by just saying like they use the gravity, they detect the gravity or whatever. So one of the things is that like planets in general are magnitudes, orders of magnitude smaller in mass than stars. And so that means that like gravitationally they don't have much influence, right? Like our sun kind of sticks in the middle of the system because the center of mass of like the Earth and the sun. We talked about this before. The center of mass between the Earth and the sun is like inside the radius of the sun.
Okay.
So like these planets that are in other star systems that are orbiting the planets kind of have the same thing going on, where they're not really influenced a ton on the planets or on the stars, but they are influencing that. So that's the type of stuff that they are looking for. And there's actually 5 different methods that they use to find exoplanets. So the first, there's 2. So there's 2 that really, now there's more than 2 that are gravity based, but there's 2 that use like the fact that the star and the planet are the planet is orbiting the star. So those 2, I'm just going to say these and then we'll go back and talk about them. The first one they call like radial velocity, and the second one is astrometry.
I mean,
they call it.
Root words based. Are they measuring stars?
For that one, yeah.
Okay. Astro, star.
So let's talk about that one
measurement.
first. Astrometry. So what they do with that one is they take a picture of the sky, and they kind of like they take a central star that they're investigating, and then they measure the distance between that star and other stars nearby it in the sky. Okay. So in theory, those should be like static more or less in terms of like in relation to each other. So then they take multiple pictures over like months or whatever, and they measure the distance like from each of those stars from that central one they're investigating each time. And they'll see that like at one point it's a little closer to the one that's below it, and then the next point it's a little closer to the one to the right of it, and another point it's a little closer to the one above it, and like in a cycle. And what they see is that means that star is kind of moving in a circle in the sky when they look at it, and that's because there's a planet that is orbiting around it. But you're seeing, I said this way a long time ago when we talked about it, that the star and the planet system rotate around their center of mass. And so that's what you're seeing is you don't see the planet. You just see the star going around its center of mass in a little circle, which implies that there's a bigger entity that you don't see going around that star.
Okay.
Oh.
So that's
Can somebody see this with the naked eye, like
astrometry.
in our sky?
No.
I feel like that's
Okay.
kind of what I was getting at when I was talking about a void. Like you're noticing the things around it to see what isn't there to then make the
Okay.
that's maybe I didn't phrase it right, but that's kind of what I was implying, insinuating, trying to get to.
Mm-hmm.
That they're using what they can see to like infer what they can't.
Yeah.
I think that's more what I meant by like a void, like what's missing.
Okay.
See, I was right.
Okay.
Are you just saying okay to appease me right now?
Yep.
Okay, cool.
You
You don't know inside my brain.
So radial velocity, you have the same setup, but what they're doing is they're looking at the light from the star specifically using spectroscopy. Okay. They can measure the wavelengths that are coming from that star, because stars like kind of burn consistently with a certain amount of energy. And so you like look at that star measurement at one point in time, and at a different point in time you'd expect the same spectral profile from the star.
Mm-hmm.
But what happens is, have you ever heard the terms like blue shift and red shift?
No.
Maybe not on what they are, but like just kind of thrown out there before.
I feel like I've like those phrases
No.
sound familiar, but I've got zero context for it. Like I couldn't tell you what they meant at all.
Yeah, so this is the Doppler effect.
Ew.
Yeah, so that's the like with audio, we experience the Doppler effect here on Earth when something's coming at you with a speed and then passes by you, and the sound pitch goes down.
Think about like sirens.
Oh, yeah.
That type of thing. That's called the
Mhm.
Doppler effect, because when the thing is traveling towards you, it makes the observer experience a different frequency than the actual signal that's being sent out, because the thing is moving, and it actually like smushes the wavelength of, well, it doesn't smush the wavelength, that changes the frequency, but what you experience is a different wavelength in effect. And then when it goes past you, then it's going away from you, and so it stretches out the like effective wavelength that you hear in sound.
Mm-hmm.
Well, the same thing is happening with light when things are moving in space. So if the planet is going around in a circle like this, at one point it's coming towards you, and at another point it's going away from you. So if they measure the light at the point where it's going towards you and take a look at that spectral profile, and then when the star is going away from you and taking that spectral profile,
Mm-hmm.
in the profile, they see the same exact profile, just shifted in wavelength of light that they see.
Okay, I'm following.
So you would expect if the sun, oh my gosh, if the star was not moving, every time you look at the profile, you'd see the same thing. But if you see it shifted one direction at one point and a different direction at the other point, then you know that star is
rotating,
going around in a circle,
orbiting
something.
Sure.
So that's
that's kind of what I was getting at. Duh.
Good job, Kelsey.
That's the radial velocity method.
Thank you.
So those are two methods. The next method is called the transit method. Any guesses for what this is?
I mean, transit equals
it's like
travel.
The speed from point A to point B.
No, wrong. So this is when
Wrong.
a planet is orbiting a star, but the planet actually passes in front of the star when we're looking at it. So kind of like an eclipse with the moon, but with the planet that's orbiting the star when we're looking at it way out in the distance. So what we see is a star out there, and we should see the same intensity light coming from it at all times. Well, if we look at it and then all of a sudden it loses intensities to some degree and then brightens back up to what the normal intensity is, then something passed in front of it.
Okay. See, I said travel. I wasn't completely in left field.
All these things are traveling.
Well, okay. Fine.
But yeah, that's specifically. Okay. So that's the transit method. Then there is a direct imaging method. Okay. But what this relies on is they kind of have to have an idea that it's happening beforehand. But what they can do is they can point a telescope at a star, and then what they do is they kind of put a little patch over the section of the telescope that's getting the light from the star. And it's like, I mean, we do this here, if you put your hand in front of the sun, then you can see things around it better, right? So that's what they do with the telescope, is they cover up the star, and then that reduces the intensity that the camera is seeing enough that
creating an eclipse would that be the right term?
Well, not really, but in that case, the light, because just like in our solar system here, all of the light that we see from any of the other planets is actually reflections of the sun's light coming back towards us, right?
Sure, I did know that.
So that's what we can see with direct imaging, is that you cover up the star and then it reveals a planet where the light is being reflected off. The light from that star is being reflected off of that planet and then towards us, and we can see it directly with an image. So that's the most looking at an actual planet outside of our solar system we can do. The last one is a tricky one. It's called gravitational microlensing.
Oh, shit.
Okay. Sounds tricky.
So this has to do, I don't remember how much we talked about this one with gravitational lensing and when we talked about general relativity. So remember how I talked about how the ball in a fabric example, where
I do remember that.
You have to think about it in 3 dimensions, right?
Yep.
So in this case, you have a star that we're looking at that has a planet orbiting around it. But in the distance, when we're looking at it behind that star, there is another star in the distance behind it.
Okay.
And that star is also sending light to us. But because the star that we're looking at that's closer has a lot of mass, and therefore there's a lot of influence of gravity in space there, the light that's coming from the distant star is going to get bent when it goes through that fabric of the nearer star. Okay. And so it acts like a lens, like a normal lens, like you would think here, where you shine light on it and it focuses the light into one position. The light getting bent around from gravity, we see a spike in the brightness of the star behind it.
Okay.
When that happens.
I'm strangely following this.
So, but with a planet, the planet does the same thing, but a smaller amount. So what they'll see is, they'll kind of see a gradual, if there's a star where this happens and there's no exoplanet, they just see a gradual increase in brightness and then decrease over time. But what they'll see if there's an exoplanet going around the other stars, they'll see that same gradual, and then all of a sudden there'll be a second bump in that brightness, because that's focusing the light more. And so instead of the normal curve you get a little bump in the middle of the curve.
Hmm.
Because it's doing the same thing that the star is doing, just on a smaller scale, because it's much less
Right.
massive.
Yeah.
So, all right. That was a lot of information, but that's the 5 methods that they detect exoplanets.
Can we pause for
Okay.
my own question?
Yeah, go ahead.
How many exoplanets have we been able to identify?
Which method has found the most planets? That's my second question.
Look at me. One step ahead.
The second one that you were talking about.
The radial velocity,
No, I was going to go
Yeah.
with the first one.
the astrometry.
Yes.
Astrometry is the one we found the least with.
Oh, really? Okay. JK. Then I want the light one, the light gravity one, the last one.
That's in the middle.
Fuck me.
So am I right?
That's the second most.
So which one
Oh,
is the most?
damn.
The transit method is the one we found the most.
Okay.
Oh, okay.
So how many have we
That's
found?
the one I think I understand the most.
So we've found about 6,000 planets.
Holy shit. That is much larger than I was
Wow.
expecting.
I thought you were going to say like maybe like 60,
I was gonna say like,
45.
I was thinking like 47. So when we said we found 6, and I thought it was just gonna be 6, I'm like, oh, okay, 1,000.
Yeah. So
Fuck.
4,500 about from the transit method, 1,100 from radial velocity, 250 from the microlensing that we just talked,
Mm-hmm.
84 from direct imaging, and 5 from astrometry.
Of course. So here's my next question. I have all kinds of questions.
Mm-hmm.
So when have these all been discovered in the last 20 years? Is there like a range of time frame where they've all been like what's
I
kind of the
mean, on
timing
the scale of
this?
things, recent. Not all of them in the last 20 years. I think the first one is I didn't look specifically, but I would say in the second half of the 20th century
Okay.
and up to now.
Oh, wow.
The majority of them have certainly been in the last 20, 30 years
Yeah.
with
okay.
the Hubble telescope. And bigger and better ground-based telescopes.
Oh.
But these are really, really hard to do good enough imagery in order to do such precise measurements. So that's why we need something. We need the telescopes like the James Webb Space Telescope to look at these things. Because ground-based telescopes, they have to contend with the atmosphere and clouds and all these things, and they make the photography really, really bad,
Mm-hmm.
relatively, for this type of work. So James Webb Space Telescope is going to be incredible for this line of research.
Has it identified any exoplanets yet?
I didn't look specifically, but I think it has.
Okay.
Yeah. It's just so much better at
Wow.
this type of thing. So one of the things that makes one of these methods more successful than the others that you have to think about is the orientation that we see the star system. Okay? So astrometry, kind of the reason that that's the least successful is because you can really only do it if the plane of the star system is perpendicular to our vision. So basically we're looking top down of the star system because we
It
can
has to be
only
perfect
see it
in order
because
for it
it
to
has
work.
to, because we have to see it going in a circle like this. So all the planets are going
Mm-hmm.
would be going like this. And in a thing that is not limited in terms of degrees of freedom, it's really hard. You have to find the perfect setups. So the transit method also, now it's the most successful one, but also you can only use it if the star system is edge on to us for the most part, right? There's millions
So
of
that's
stars.
why they use so many different methods.
Yeah, there's millions of stars that probably have planets, but they're in the other situation where we would never see a planet transiting them because they aren't oriented the right way that we can look at it. Now,
Mm-hmm.
the advantage is that stars end up, in terms of size, orders of magnitude larger than the planets. So like even if the angle is off a little bit, you still might at some point have the planet pass in front as far as we can see it, because the planet is teeny tiny in comparison to the star's radius, right?
Mm-hmm.
But yeah, the orientation is a big thing to do with what's going on here.
All right, I have an answer here.
Okay.
So this is from the end of June. So we're talking a month and a half ago. The James Webb Space Telescope just made its first direct imaging discovery of an exoplanet. So it's only found one, but like literally a month and a half ago.
Wow. Cool.
Called TWA7b. Super exciting. Which is similar in size to Saturn. Says this is a significant milestone as it's the first time that the James Webb Space Telescope has directly imaged a planet outside our solar system. The planet orbits a young star called TWA7, located 111 light years away.
Holy
Relatively
cow.
close.
So, yes, they have...
What? Relatively close?
Mm-hmm.
In the grander scheme of space, yeah.
Oh my god.
So, yes.
That's like
Galaxy is like
much
100.
farther than I assumed.
Oh. The nearest star is like 3.5 light years away. That's near. That's really close by. The galaxy as a whole is like 100,000 light years across. And ours is a kind of a small galaxy, actually.
Wow.
Kelsey's going to start crying thinking about how big the world is.
Yeah.
I know.
So like if 1,000 light years is 1% of the width across the galaxy, we're talking about 100 light years. So that's 1% of 1% of the width of the galaxy away from us.
Wow.
So yeah, relatively
that makes
close.
You feel really small.
Yeah.
Yeah.
That's one galaxy.
Well, because, you just wonder if there's like other people like us in other galaxies or planets somewhere that are doing like the same studies, and like they can, or like that have some kind of different technology or something.
No, this is my perspective when anybody talks about like, is there any other intelligent life out there? I'm like, there's no doubt in my mind there is.
There fucking
Could
has
we
to be.
ever make contact with them?
No.
It's hard for me to say unless they've discovered some physics phenomena that let them cover space in a manner that we have no idea how to utilize at this point.
UFOs.
Yeah.
But like, we're one galaxy. We
are one solar system in
billions
one
of other galaxies. Yeah. That are just so far away. They're inaccessible besides by looking at them. So.
Yeah. Wow. Mind blown. That's
crazy.
This
is wild. Like it's.
I didn't really do a whole lot of like. This is kind of the end of what I had gotten for today, but to like talk about some other things, like there's a thing called the Drake equation, and there's a thing called the Goldilocks zone, and so
I've actually
heard this one too.
Yeah,
from Dr. Binox. I think that's where I've heard about it.
Well,
I don't remember anything, but
in any case, based on what we, with our experience here on this planet, know about how organic life can synthesize, like Goldilocks is a great term for it, right? Because like the Earth is in the
not perfect, too hot, not too cold.
Perfect distance away from a star, with a rocky core with water on it and lots of carbon, and we're here. So that's like what they're looking for in exoplanets is, is there a star that is this temperature, and is there a planet that is made of organic material with water around it at this distance away? All those for them to be like, is this a potential planet that could support life type of thing?
Yeah.
So.
Wild.
Yep. So my last question here on a different
That's
track,
crazy.
but what's the biggest? How big is the biggest exoplanet that they found?
Twice the size of Jupiter.
Okay.
I have no idea. I said that very matter-of-factly. I just want to preface by that was straight out of my butthole.
Yeah. Okay, so the one that the new telescope just found was about the size of Saturn.
Correct.
I'm going to say the biggest one they found is like, wait, is Saturn bigger than Earth?
Yeah, a lot bigger.
Okay, so the biggest one I'm going to say is like 5 times the size of Saturn.
Okay. So the interesting thing is that they do measure it in terms of masses of Jupiter. Like that's the unit that they use to compare these things. Which is funny that you say that, Kayla.
Okay.
I'll say it makes me sound like I did an even better job, and I did no idea.
So now, actually, the biggest one
How
they
big is
found
Jupiter
is a lot
compared
bigger
to
than that.
Earth?
To Earth, even bigger
Fucking
than
huge.
Saturn.
Jupiter's the biggest planet in our solar system.
Oh,
Yeah.
okay.
So, well, there's a whole debate about what is a planet. Okay.
No, we're not going to start with
We're
this
not going to go
Pluto
down
shit
that.
again.
But let me just say that there are objects that are bigger than what I'm about to say. But there's a big debate about whether that's a planet or not. Okay. But the biggest one that's
Okay.
kind of like definitively a planet that they think is about 12 to 15 Jupiter masses
Holy shit.
large. Our solar system
Wow.
is generally a smaller system in many regards. Like the sun is a small star.
No,
regard.
my star is the
What?
biggest star. It is the best star that has ever been a star. I live
Many
in the
people are
best.
saying
Many
this.
people are saying this. Everyone knows that my star is the biggest star and the best star.
Thank you for your attention to this matter.
Everyone,
it's
I mean,
tremendous.
have you looked in the sky recently? It's very big. It's very bright. You all are
That
welcome
was
for that.
actually really good.
I know. Thank you. You all are welcome for that little free show.
So yeah, like they've found things that are like 30 plus times bigger than Saturn orbiting other stars. But it's kind of hard for them. They kind
Did you
of
mean, okay, hang on, back up, because we've been talking about in masses of Jupiter, and now you said 30 times bigger than Saturn.
Oh, I'm sorry.
Did you
Kelsey
mean
got me
Jupiter?
on that. I meant Jupiter.
Okay, I was just checking.
Yeah, I meant Jupiter.
Good job, Kelsey.
Boys
But
go to Jupiter to get more stupider.
Girls go to Mars to get more candy bars.
just I won't go into it, but like the debate there is that those objects are likely made up of gas, and we're kind of unsure of whether the gas is ignited or not. And if it is, it's like at a low level, or it's more likely like it is ignited gas, but it doesn't give off light like a star does. But they call those brown dwarfs. I mean,
Is that PC?
what? Yes.
Okay.
I don't know. That's what they call them.
Okay.
Nobody's had a problem with it. So yeah, I mean, people kind of thinks that Jupiter kind of is, they call them like failed stars because they're made up of gas, and like they just didn't get to the point where they got big enough that they start crushing the gas to ignite it. We talked about that the gravity pressure is what
Yeah.
makes the fusion happen inside of stars. So it's like at some point when you're accumulating mass, that starts happening. And there's kind of this like crossover zone where it's like, well, is it a planet or is it a star type of thing? So that's where the debate is. Okay. And then last thing, what's the smallest exoplanet that they found?
Half the size of Pluto.
I mean, the size of Pluto.
Oh, well, you're both on the right order of things, I would say. What I found was 0.3 times the radius of Earth. So a third the size of Earth. Well, not quite, but the radius 0.3, the size of Earth, which is pretty dang small. But Pluto is very small too, because Pluto's not a planet, remember?
Okay. Right. That's right.
All right. Well, there's lots more that we could talk about this, but that was what I had, was how we find them and kind of like what size that we found so far.
I made for you all, because I was ADHDing really hard. It is a balloon bouquet of planets. You're welcome. Look at that.
Oh, that's beautiful.
That makes sense
Exoplanets
for our
or regular
topic, but-
planets?
No, these are exoplanets for sure, but they're being held together by a balloon string because they're balloons.
Well, this
Cool.
paper is on our solar system, so clearly they're not exoplanets.
Oh, well, shit. Not exoplanets. But you're welcome for my artwork.
Thank you. Thank you.
No, I find
Highly
all
impressed.
I find
Also
all
impressed
stuff.
about this topic.
No, I find all stuff like space related super interesting.
Yeah. I just think the
Yeah.
strategies.
I mean, my
for
mind is
finding-
pretty blown, honestly.
Yeah, the strategies for finding exoplanets I've always thought were really interesting.
That's wild.
I mean, in general, I just like the people that think up this experiments for determining different things takes a lot of like creative leaps to just like, how did you think of that
Right.
to try to measure a
Yeah.
certain thing or whatever.
Do you
But-
want your topic for next week now?
Yeah, so I guess we're going to talk about topics for next time. TBD, and if we're going to go back to 2 topics per episode yet,
We'll find out.
the potential 2 topics
We'll
for
find
the
out. It's
next
going to be a surprise.
for the next week or
Surprise.
next 2 weeks.
Surprise to you all, surprise to us. We have no idea what we're doing.
We're putting out content consistently. That's what we're doing.
We are doing that. We have been very consistent, minus our summer hiatus.
right.
But, like, I mean.
Yep.
All right. Here's your topic.
Yep.
You're going to talk about wave particle duality.
Okay. Yeah, we talked about that a
Ooh.
little bit a couple
Cool.
weeks ago. And yeah, I'm really excited to talk about that one too because it's really, really important. Kind of was the precursor to everything that we formulated for quantum mechanics. So
Hell yeah.
really, really interesting and good topic. So cool.
You're welcome.
All right. So I think the topic I'm going to give you for whenever you do a topic next is dealing with parents.
Okay.
We kind of talked about it a little bit the
Ooh.
last episode
Yeah.
with the grading, but I think it's we want to hear your war stories.
I was going to say, this is going to be entirely anecdotal. Like, you
Yeah.
realize that, right?
Yeah,
Like
no, this is more of a
There
like
is
tell
no
us,
research. You want the war
Yeah.
stories.
Yeah.
Okay.
give us your most interesting stories of dealing with parents. I guess I would like to just get a little bit of a like, what do teachers like? How do teachers vary in their approach of how they deal with parents? So
Okay.
And what you're trained for, specifically.
I'm,
In that
I'm
area.
trained for I'm trained for hanging up the phone. We'll get there. We'll talk about that.
Okay.
Kelsey is like concerned. No,
Oh, yeah. Well,
you'll find
I'm
out.
not.
You'll find out. All right. This has been real.
That sounds lovely. This has been real. As always, like, subscribe, comment, follow, download, all of the
review.
things. YouTube, Instagram, TikTok.
TikTok, Instagram, YouTube, Apple Podcasts, subscribe.
Spotify.
Yes, all
Help us
Yes.
out.
the things.
Please.
We appreciate any interaction.
The more likes we get, the more thirst traps
Don't make
Kelsey
Jake
will
beg
post.
you.
Yeah. I feel
Hell
like
yeah.
there's an old Adam Sandler and Chris Farley sketch on SNL that I think about all the time. And it's really good because it's Adam Sandler doing his little like coy baby voice. And then it's Chris Farley yelling like Chris Farley does about like letting Adam Sandler do the thing that he's asking to do. So I'm like, please just like and subscribe.
Oh my gosh.
The Hurley Kid. Look it up.
That's funny. Well, tune in next week to find out why this wasn't on the test. Thanks for joining us, and we'll see you next time. Bye.
Bye.
Bye.